the robots are taking over. All of you have heard some version of that already, so it's not a big surprise. But I think for the creative people in this room, if your job is to do something creative, make creative stuff, you might think that your task or the thing that you do, your creative activity, is maybe immune to the robot takeover. I'm here to tell you that it's not. They're going to take over all of it. And it's not just a matter of when it's going to happen, but it's actually already happening. I'm Che-Wei. I spend half my time teaching art and design at Pratt Institute and a school called the School for Poetic Computation. And the other half I spend in a small, tiny design studio. It's just my wife and I, and we just sketch, prototype, and design and manufacture things that people are willing to pay us money for. As designers, we're super interested and invested in how technology influences our design process. So anytime there's a new piece of software or a new piece of technology, we're always evaluating it, and seeing how it could work into our existing workflow. And so over many years, the last 10 years of our studio, we have built up a workshop where we have this software and hardware workflow where we can take a napkin sketch and turn it into a fully functional prototype in less than a day in most cases. And so if you run a studio like ours and you use the technologies that are out there, you probably probably know what it feels like. It feels like having this little superpower with this technology to be able to do what feels like maybe 20 people's worth of work from 10 years ago. I want to quickly show you a little sampling of some of the work that we do to give you a sense of where I'm coming from. So we sometimes design buildings, so an architectural practice. So this is a residence in Tokyo. We mostly work in machine metal work. So this is a titanium key holding solution called Key Wrangler. We work a lot with precision machine metal. So this is a pen. I brought one that is really precisely machined. And it makes this nice popping sound when you pull it out. Ready? And then it drops in really slowly because of the tight tolerances between the parts. We sometimes also work with electronics. This is a product that we make called Time Since Launch. It's a single-use launch clock. So the idea is that you pull the pin, and that's all it does, and it just counts up. You can't reset it, you can't stop it, and it's a way to mark a moment in time, and it counts up to 1 million days, so days, hours, minutes, and seconds. I also love building bicycles, so I love this town. It's amazing. This is called Pelican. It's a strange, weird cargo bike where the pedals are attached directly to the back wheel so that the cargo bay could be really big and the wheelbase really short, or as short as possible. So this is how we design physical objects today. And all of what I just showed you gets designed like this. Most of what we do as designers of physical things is we sketch out ideas. We use CAD to increase the precision so we can lay out the dimensions, work out a bunch of parts, make sure they all fit together. And that's sort of the path that we've been on for a while. And as much as CAD tools has enabled us to make more and more complex objects, the meat of the design process happens because we, like human minds, synthesize all the rules, the desires, the wants, all the constraints, and then it's up to us or a team of people to come up with a design solution for whatever problem's been set out. And so the past 30 years, CAD tools have been on the same development path. They've just been producing tools to help with a human intuition-based design process. And we're at a fork now, and I think, it's pretty clear, I think, with recent developments in machine learning and generative design, we're on this fork where the future looks like a place where all our desires, our needs, wants, all these other fuzzy things get encoded into data so that those things could be optimized and engineered in an automated process. So first, I want to show you where we are along this path. I want to point out some dangers in going along this route. And then I also want to offer and present an alternative as we move towards an intelligent machine-based design process. So a few years ago, I started using this piece of software called Autodesk Generative Design. It's a recently available tool. It's commercially available, made by Autodesk, which is one of the biggest CAD software companies in the world. This is a CAD program that leverages cloud computing, which we all use in some way, to generate designs out of thin air. So to explain what I mean by that, and I want to show you how it works, I'm going to walk you through how I designed this thing. This is a bike stem that I designed in Autodesk Generative Design. It's an ultralight bike stem that's 3D printed. So the first step when you work in generative design is you want to first manually draw the parts that you know you need. So for a bike stem, I know I have to clamp onto the fork, I know I have to clamp onto the handlebars, and I know the distance that I need. So I manually input those. So that's a human input. And then I also have to describe the forces that I want this to withstand. So it's a bike stem, so I have to be able to put weight on it, pull on it, twist it, put on lots of torque. So I input those also manually as a human. And then I draw the boundaries for where I want this algorithm to work. So I'm telling it, don't put material in this area, only put material in this zone. And that's it. I haven't shaped it. I haven't described what I want it to look like. And at this point, I hit the start button. I click start, and then the algorithm takes over. So when the machine takes over, it first generates a random blob that respects the boundary that I set up. And then the machine runs a stress test based on the inputs that I set up earlier. So those forces are now being applied. The machine is testing to see what material is necessary and what material is not necessary. And then it removes the material that it doesn't need, does another stress test, removes more material, and it does this over and over, many thousands of times. So it sends it to the cloud. The cloud has lots of servers running. So if this can run in the cloud really quickly, and it keeps doing this until it finds this optimal form. And this final form is the least amount of material needed to support the constraints that I set up earlier, the forces, the boundaries. You can also set up manufacturing constraints and material constraints. And at this point, if I like the design, I can save it. I can send it to get 3D printed out of metal, get shipped back to me, and I can assemble it on my bicycle. And so that's what you can do with commercially available software today. It's not coming soon. That's what you can do right now. And so with lots of cloud computing, I can keep generating many different options. So instead of me drawing things, I just tweak a few things and then generate lots of versions. And as a designer, what I do is basically select the ones that I like. And I think, in some sense, I've essentially transferred all my ambitions, my desires, in some form into data in the form of forces and boundaries into the computer. And so what used to happen in sketches and in CAD is now fully on autopilot in the machine. Generative design is really good at topological optimization, which is the process of optimizing a shape to use the least amount of material for a set of forces. It's so good at it that it's actually really hard to make stuff in generative design that doesn't look like alien skeletons. You just get stuff like this. But this is really optimized, so we're just going to keep making stuff like this, and the software is also just going to get better at making stuff like this. This is a quote by John Culkin, sometimes also attributed to Marshall McLuhan. We shape our tools, and thereafter our tools shape us. And I feel like CAD tools now are shaping us. It wants us to define our inputs as numbers so that every aspect of the design, the texture, the ergonomics, the aesthetics, could all become engineered and optimized. And so that's the path that I think we're on right now. I think every creative task eventually will have a machine-based equivalent that will do it better and faster than any human can today. AI-powered design bots will be superhuman designers. Their work will be clearly distinguishable because it'll be so much more superior than what we make. I want to just show you this example. This is an antenna designed by an evolutionary algorithm at NASA in 2004. So this design evolved, so this final design evolved in a simulation over a few minutes to become the best possible antenna for the constraints that they set up. And it looks so weird, and I don't think any human would ever come up with a design. It just wouldn't occur to us. And you can't really argue with this because it is the best. It performs the best based on this set of constraints. But there's a problem with this. AI tools are digital black boxes. Every bike stem that I generated was a complete surprise, which is maybe good, because I like surprises, but it's always not exactly what I wanted. And to get the design to be perfect, I have to tweak a bunch of variables. And when I tweak a bunch of variables, it just resets the whole universe, and it has to generate from scratch again. And it's essentially like the butterfly effect in software. I don't really understand why it generates what it generates. It's really, really hard to predict how, when I tweak a bunch of variables, how that affects the actual outcome. And so we've handed over, in that scenario, our intuition into this black box. When we willingly hand over our intuition to black boxes like that, there's a risk of building stuff like this. This is Faceception. What you see here is a machine learning algorithm that does some face detection and gives a score to the person on how likely this person is a terrorist. So this person is 79% likely a terrorist. And I have a question for you all to think about just for a second. How is this algorithm, what are the rules for this algorithm to generate the score? Right? The hint is, I don't know. You guys probably don't know, and the people who make this also don't know. Because the way we train machine learning algorithms is not by setting a set of rules. We don't write code to train machine learning algorithms. We train them by showing the results that we want. And the algorithm just rewires itself so that it could generate the results we want. And so we don't know how it works. We don't know how it's generating the result. We'll just keep training it until we get the results we want. So if this company, Faceception, succeeds, they will end up with this totally opaque black box that will automatically give a score to every person's face on how likely they are a terrorist or a drug dealer or many other things. And if they're successful, they will sell these boxes to governments and security agencies all around the world. That's a little bit scary to me. Spam filters, product recommendation engines, and lots of other machine learning products work under the same principles, but the stakes obviously are a lot higher here. That's a pretty extreme example, but it is real. I had to search a little bit to make sure it wasn't a joke, and it's happening now. We're heading towards a world governed by opaque systems. Computer vision and AI, they've been hanging out for a while, since the early days. So, crazy ideas like that get proposed and are actually getting funding and getting built. And I think design has a slight advantage because we're a little bit late to the game. And so we get to see how other disciplines are incorporating AI, and then we can choose to follow their lead or not. We can choose to replace every part of the design process with machines so that everything could get optimized and automated, or we can find ways to provide more human input. But I don't think we want humans just as backup. We can't be the hands on the steering wheel just in case the autopilot messes up. I think human intuition and emotion are maybe the only things that AI eventually isn't able to replicate. And if you value those things, we should find ways to keep them in the loop. And so we need ways for machines to accept feedback and fuzzy human desires, like I want this thing to be more playful, or I want this thing to be more robust, right? Those need to become meaningful inputs for machines. So imagine if a generative design software can learn all your preferences, and it would just present a bunch of options to you, and your job is to just say, this is ugly, this is beautiful. And so the more you interact with it, the better it gets at predicting what you like and generating things that you like. Kind of like Amazon's recommendation engine, but for design. Or you could just feed it a ton of training data from the beginning and just train it on all the designs that you already like. And so it actually only knows how to make stuff that you already like. And that might sound a little bit crazy, like a little bit sci-fi, but we're actually very close. You've all seen Stahl Transfer stuff like this, where you can feed it an image, it could spit back an image based on Van Gogh or Monet or any other kind of style. This is widely available. Everybody's phone can do this now if you're connected to the internet. This is a machine learning algorithm out of MIT called 3D GAN. So what you see here are, in red, 3D models that have been generated from a single 2D image on the left. This algorithm's been trained on data of furniture, three-dimensional furniture. And I would argue that this algorithm understands the essence of furniture. It knows how to pick it out and knows how to generate it based on very little information. So I think we're not far from training machines to generate three-dimensional objects based on any particular style that we want. With enough data, you can train machine learning algorithms to generate practically anything you want. You can generate portraits, cars, sneakers, faces. So what you see here is just a machine learning algorithm generating new images on this infinite grid as I pan around. So this face generator, for example, you may have seen stuff like this, deep fakes. It's trained on a ton of existing images of real people's faces, so it can now generate photorealistic faces of people that don't exist. But it also knows how to detect photorealistic faces. So it's constantly generating faces, checking to make sure what it just generated is in fact realistic or not realistic. And so it's training itself as it generates these images. And these image generators, they're pretty commonplace now. There's lots of them out there. And I think sophisticated 3D model generators are just on the horizon. Imagine training an algorithm on images of chairs that you already like, or maybe you don't like, and you label them accordingly. And then this algorithm would just generate new chairs for you, and you provide feedback. And when you find the one that you like, you click, I want that, get it sent to be printed, and then shipped to you, and then you have your final design. We've been painstakingly drawing and reworking our sketches in CAD for the last 30 years. And we now have technology that can take over many aspects of the design process, if not all of it. And so we could hand over everything to the robots, or we can build generative design software aided by human intuition and emotion. This is a piece of software I want everybody here to try. There's no excuses. It's free. It's called Runway. If you go to runwayml.com, you can download it. This is a machine learning tool built for creative exploration. It's not meant for people who know how to, it doesn't require any code knowledge. You don't need to know how to code. In 5 clicks, if you follow the mouse, in 5 clicks, you can generate cat images or rainbows or whatever. There's so many machine learning algorithms and models out there, and they're already built into Runway. You can just explore them. So please try it out. There's this thumbnail exploring interface that I've showed a few times now in Runway that I have a lot of hope for. This gives me, so much hope because it's so intuitive. By mapping the variables associated with how the machine generates these images, I'm able to provide immediate feedback. Right? If I see something I like, I can just keep panning in that same direction, and it'll keep generating similar images of that style in that direction. And if I see something I don't like, I can just move away and explore a different direction. And the algorithm responds in real time. But imagine if you could do this in 3 dimensions, or even higher dimensions. If you map all the variables, not just some of them, but all the variables associated with generating an image or a 3D model, and you embed them in virtual space, there would be no sliders, no text boxes, no mysterious knobs to tweak. And so designing in the future might just mean exploring an infinite space of possibilities. I want to end on this note. AI is just another tool, right? It's not a magic bullet that's going to solve all your problems. But it's also not just another tool. It's a tool with superhuman potential. And engineers have already embraced them. And designers, I think we need to start hanging out with them more. Thank you.